Okay, here's the recording in progress. Okay, one adjustment on the homework. I've decided to skip problem 23 from 4.9. I don't like the way that they worded the problem in terms of north and east and so on. So we'll just skip it altogether. Okay, if you did it, great. If not, skip it. Okay, so skip 4.923. Okay, so we're practically done with the chapter. I was going to do some more problems today, and that should finish everything up. Okay. And then we're finished. I'll let you ask questions in preparation for the test. If not, I'll do my own review today and tomorrow. And our next exam again is Friday. Okay, we haven't had an exam in a while. It's been almost literally a month. But in any event. Okay, so you know the rules. Submit the homework. You have half an hour after the exam ends to submit the homework, but if you want to submit the exam early, you may. Okay, and you can have one formula sheet and a calculator, but that's about it. Have your camera on. You join the Zoom, camera on, true background. Keep yourself muted. Any questions, put the questions in the chat. Okay, and speaking of chat, I do see something coming in. Okay, so can we see certain problems? All right, so let me go ahead and do what I was going to do. And then we'll see after that. Okay. Okay. Problem 15 on the homework. So mentioning solve for the missing parts of the triangle satisfying A equals 125, B is 150, alpha is 55. There are two solutions, so that's much longer problem than we're used to. Okay, ignore any dates, of course. So I've got two different triangles here. Okay, so how come there's two triangles? There's going to be two solutions, as we shall see. Okay, so first let me draw the triangle. Ignore temporarily the reds are the final answers, derived answers. But we're starting with A is 125, alpha 55, B is 150. Okay, that does tell me I can use law of sines because I have A and A. Okay, remember, in order to have law of sines, you have to have either A and A, B and B, or C and C. So I have sine of 55 over 125 equals sine of beta over 150. And I don't have anything for C, but don't worry, we will. All right, so what's going on here? Let's cross multiply as usual. 125 sine beta equals 150 sine of 55. Divide both sides by 125. So sine of beta comes out to be 0.9830. Okay, now here's the tricky thing about it. If you do inverse sine on your calculator, you get 79.41. That's fine and dandy. Work out the rest of the problem. However, there's a second quadrant angle that also works, that satisfies this. Y coordinate, you want the Y coordinate to be 0.9830. So if you think of a unit circle, where can I sneak this in? For a given Y coordinate, there's an angle here, but there's also an angle here. Your calculator is going to give you 79.41. You want this angle, which has a reference angle of 79.41. Okay, so that would be 180 minus 79.41, which is 100.59 degrees. So 79.41 is fine. What about 100.59? If I put 100.59 plus 55, I still would not have exceeded 180 degrees. So yes, there are two possible triangles that work. One where beta is 79.41 degrees, one where beta is 100.59 degrees. Okay, so one more time. Sine of what angle is 0.9830? My calculator is only going to give me the quote unquote nice angle, first quadrant angle, 79.41. But 100.59 would also satisfy this equation. In other words, the sine of 100.59 is also 0.9830. And that works for this triangle. Now you might say, well, how come you never did that before? We actually did, but there was something that prevented us from doing that. For instance, the sum of the angles already exceeded 180 degrees, so we knew that wasn't possible. Or maybe there was a violation of largest angle opposite the largest side, opposite angle opposite the smallest angle opposite the smallest side, and maybe that would have been violated. That's not possible. Okay, but here's our first instance, and actually our only instance. So you should be glad there's only one that we're going to do, where there's two possible triangles, and they have to be worked out separately. Okay, so this is case one, case two. So ignore this right now. So if I have beta is 79.41, once I have these two, you can figure out C, or gamma rather. So it's just 180 minus, sorry, case one. Beta is 79.41. So gamma is 180 minus 55 minus 79.41. That comes up to be 45.59. Then I go back into my law of sines again. So you sine of 55 over 125 equals sine of 45.59 over C. Ignore the middle one. Okay, so the first fraction and the third fraction. Sine 55 over 125, sine 45.59 over C. Okay, cross multiply. C sine of 55 equals 125 sine of all that. Divide by sine of 55. Punch it in the machine, 109.01. So case one, C is 109.01, beta is 79.41, gamma is 45.59. I put those all back here now in red. So now the triangle is solved. That is one solution, case one. Okay, so I now have all three sides and all three angles. Quick check. Largest angle, largest side, correct? Smallest angle, smallest side, yes. Now for case two, where beta is 180 minus 79.41, which is 100.59. That still works. That's within the quota of 180 degrees. So 180 minus 55 minus 100.59 comes out to be 24.41. So gamma is 24.41. Then I keep going. So plug in here again. Sine of 55 over 125 equals sine of gamma over C. Same thing, cross multiply. C sine of 55, 125 sine of 24.41, divide by sine of 55, punch it in the machine, 63.06. So my angles are beta is 100.59 degrees, gamma is 24.41, and C is 63.06. So I have two possible triangles that satisfy all of this. Again, a quick double check. Largest angle, largest side. Yes. Smallest angle, smallest side. Yes. Right. So this is sometimes called the ambiguous case of the law of sines with two possible answers. Okay. Okay, a couple of word problems and I'm done. Again, skip 23. We're not doing 23 anymore because I don't like the wording that they had there. 21. Points A and B are on opposite sides of the river. Here's the river. Let's see, where am I? To find the distance between the points, a third point C is located on the same side of the river as point A. The distance between A and C is 45 feet. 45 feet. Angle ACB is determined to be 42 degrees. Okay, you can measure that. Angle BAC is 105 degrees. Find a distance between A and B. Okay. So before going on, I want you to notice the practical use of trig. I'm trying to find this distance. It's across the river. Well, maybe I don't feel like going on the river. I don't feel like walking on the water and measuring this. But you can walk on the land and measure out 45 feet. That's easy to do. And you can measure some angles. This is 105. This is 42. That's not too hard. And then use trig to determine this distance that I'm not going to measure directly because I don't feel like walking on the water and measuring the tape or so on. Yeah. I can derive this angle. I may not be able to get this angle because I'm not on that side, or maybe this is enemy territory or something like that, right? But we can use trig to figure this out. Okay, so they gave me 42, 105. You can take 180 minus the sum. Let's see, 105 plus 42 is 147. 147 subtract from 180 is 33. All right, then I can use law of sines, it looks like. Sine of 33 divided by the side opposite, 45, is equal to sine of 42 divided by the side opposite, which is x. And there we go. Cross multiply, that times that times that. X sine of 33 equals 45 sine of 42. Divide by sine of 33, punch it in the machine, 55.29 feet. Okay, so the distance across the river from A to B can be worked out to be 55.29 feet, even though I never actually stepped out and walked on the water and measured the distance across and so forth. Okay. Okay, and then 25 is the last one. The National Forest Service maintains observation towers to check for the outbreaks of forest fires. Suppose two towers are at the same elevation, one point A, another 10 miles due west of point B. Okay. A and B. You know ahead of time that they were laid out, planned out to be 10 miles apart. The ranger at A spots a fire. Line of sight makes an angle 60 degrees with a line between the towers, 63 degrees. Contacts ranger B. This ranger locates the fire along the line of sight that might angle 50 degrees. Okay. How far is the fire from the tower at B? Okay, so another thing. How far am I away? I don't feel like walking toward the fire and getting hotter and hotter and hotter and getting my measuring stick and burn myself up, right? But I can do this, I can do this, and I can do this, and I can figure out these distances. Okay. So I'm trying to find X. They gave me 50, they gave me 63. I derived 67. Can you see how I got that? All three of these have to add up to 180. So they give me the 50 and the 63 as what, 113? 113 subtract from 180 is 67. They want this distance. So sine of 67 degrees over 10, sine of 63 degrees over X. Opposite. So sine of 63 over X, sine of 67 over 10. Cross multiply. X sine of 67, 10 sine of 63. Divide by sine of 67, 9.68 miles. All right. And folks, I am now officially done with the chapter on trig. Okay, so everything you need is already here. I did get some questions in the chat, so let me check that and work on those. And if anybody else has questions today or tomorrow, You can bring them up, otherwise I'll do my own mini review in preparation for the test. So we are on par. Instead it's falling down here. And let me check what I had from the chat again. Okay, so if anybody else has a question, you can put it in the chat. Or you can say it verbally. 4.635, 4.837. Okay, that's what I see for now. Okay, so let's go back in. Whoops, 4.635. I'm doing this one right now. 2 sine of 2t. Okay, first thing I'm gonna do is get rid of the 2t. Let theta equals 2t. And I'm going to multiply this by 2, multiply this by 2, multiply this by 2. So 0 less than equal to 2t theta less than equal to 4 pi. Right, so I'll work the problem out in theta. And of course, t is theta divided by 2. And I have to remember for theta, I can go around the circle twice. 2 revolutions. So 2 sine theta minus radical 2 tangent theta. Well, that's sine over cosine. Equals 0. So I'll multiply both sides by cosine theta. Just to get rid of the fraction, because I don't like fractions. I'm guessing a lot of you don't either. 2 sine theta cosine theta minus radical 2 sine theta equals 0 times anything is 0. Factor out sine of theta. 2 cosine theta minus radical 2 equals 0. Either this is 0 or this is 0. See, this is 0 comes out to be cosine of theta is radical 2 over 2. Okay, sine of theta is 0. That's there and there. Cosine x coordinate is radical 2 over 2. That's there and there. And I go all the way around the circle twice. So theta is 0. Pi over 4. Pi. 7 pi over 4. 2 pi. Keep going. 9 pi over 4. 3 pi. 4 pi, and 4 pi, if I back up pi over 4, that would be 15 pi over 4. So those are thetas, and theta is 2 pi. So to find t, I cut all these in half. Okay, so half of that, half of that, half of that, half of that. Pi, 9 pi over 8, 3 pi over 2, 15 pi over 8, 2 pi. So that looks like my list of t values that make this thing true. Okay, sine of theta 0, y equal to 0, that's here and here. Between 0 and 4 pi, that's 0, pi, 2 pi, 3 pi, 4 pi, 0, pi, 2 pi, 3 pi, 4 pi. Cosine of the angle is radical 2 over 2, that's here and here. Pi over 4, 7 pi over 4, 9 pi over 4, 15 pi over 4, and then I cut all those in half. Okay, 4.8.
So cosine theta equals square root 2 over 2 pi over 4, 7 pi over 4. I'm just missing something. I'm trying to see. Oh, and 15 pi over 4. That's what it is. I got confused because I did when I was studying last night. I just factored out sine of 2 theta, sine of 2t immediately. And it was different than your work, and I also had some other things wrong, but I wanted to make sure I had it correct.
Yeah, my recommendation is to do it this way. Get rid of the 2t. I don't like the 2t. Just change it quickly to theta. And it works. Okay. The longer you carry the 2t, the more trouble you're asking yourself for. So it's much better to do it this way. 4.837. Let me see what that one is. I think I did work something like that out before. Okay, so that arc sine negative x equal theta. So sine of theta equals negative x. That's what it means. I'm not taking the sine of negative x, I'm taking the arc sine, so I must be taking the sine of something else. There it is. And sorry, sine of negative theta is the opposite of this. That's a property of the sine. Okay, sine being an odd function, sine of negative theta is x. Yeah, somebody had a question?
Oh, I guess what I was getting confused about is negative arc sine of x equaling sine of negative theta.
Equal sine of negative theta. It might very well be. Yeah, let me, sine of negative theta. The sine of negative theta is x.
Yeah, like I did like my work is basically arc sine of negative x equals theta, which equals sine of theta equals negative x, right?
Okay. Come again. Arc sine of
negative x equals theta.
arc sine of negative x. Yes. Okay.
So sine of theta equals negative x.
Correct.
Okay, and so the part I got stuck on is negative arc sine of x equals theta. Wouldn't that equal negative sine of theta equals x?
Negative sine theta equals x. Correct. Mm-hmm.
But you could turn that into you could also just turn that into sine of theta equals negative x by multiplying the whole thing by -1, which is the same thing. But it's
yes.
just I was just getting confused. Like, and if I were placed with this problem again, like, would it be like we're asked to prove this, so would it be not correct to like prove that arc sine of -1 equals negative arc sine of 1? Would that be
well,
out of line?
Do it with a particular, yeah, you would not be allowed to prove it for one particular number. because all you would show is that it works for that one number, but what about other numbers? The
Mm.
whole idea is to prove it in general. So plugging in 1 is not the way to prove it.
Okay, but okay. All right, but timesing a negative sine of theta equals x by -1 would still prove it though, right? To get the same thing that sine of theta
Yes.
equals negative x. Okay.
You can multiply by -1. That works.
All right, thank you.
Okay, all right. Let's see, there's something else in the chat. Okay, so is that 4.449, 4.73, and I think 33 is what's meant. 4.449, 4.73, and also 33. Okay. 4.449. Absolute value of x sine x is function even, odd, or neither. So I replace x with negative x. It's absolute negative x sine negative x. Sine is an odd function, so the sine of negative x is the opposite of sine x. Absolute value of negative x is the same as absolute value of x. And what do I end up with? I notice I get the exact opposite of what I started it with, which means I have an odd function. 4.7, number 3. Okay, 4.7, number 3. Number 3. Cosine of 7 pi over 12. Use a sum or difference. Okay. So I do recognize 4 pi over 12 and 3 pi over 12. Because that would be pi over 3 plus pi over 4. So let me draw my unit circle. That's pi over 4. Pi over 3 is 60 degrees. This is radical 2 over 2, radical 2 over 2. 60 degrees. Does x or y look like it's halfway across? Looks like x is halfway across. So y is automatically the other number. The other number is radical 3 over 2. And then I use the formula for the cosine of a sum. It goes cos, cos minus sine, sine. Cosine, cosine minus sine, sine. Okay, cosine x coordinate at 60 degrees is 1/2. Radical 2 over 2, cosine pi over 4. Sine of pi over 3, y coordinate. Radical 3 over 2. Sine of pi over 4 is radical 2 over 2. So common denominator is 4. Radical 2 minus radical 6 all over 4. And then 33 was asked for. Verify the identity. Draw my barrier. I think I mentioned this on the last quiz. I may have forgiven it on the quiz, but I may not be as nice on the exam. When you're doing proofs for me, you must draw this line. There's a reason for it. Okay, it's to emphasize that there's not supposed to be a crossover. In fact, some of you who did this and you thought I was strange for making this, you violated the rules of multiplying both sides or squaring both sides. The whole reason for this line is to show that you cannot cross. You're not supposed to do the same thing on both sides. You work on this independent from this, then hopefully you can get them a match. Okay, so on this side, I don't like the double angle. So let's get rid of it right away. -2 cosine 2x over sine 2x, which is -2. Get this into focus here. Cosine squared x minus sine squared x. I'm trying to get this in focus. Equals 2 sine x cosine x. Cancel, cancel. And well, how about I distribute the negative? Opposite of cosine squared minus sine squared is sine squared x minus cosine squared x over sine x cosine x. And that's probably all we can do on that side. So I'll leave that alone. So change this to sines and cosines. Sine x over cosine x minus cosine x over sine x. Common denominator. Sine x over sine x. Cosine x over cosine x. Sine squared x minus cosine squared x over sine x cosine x, and there it is. They do match. All right. So I believe I've caught up with everything. Let me check the chat one more time. And yes, I think I've caught up. Okay. You can ask me more questions. If not, we're done. So tomorrow you can have the entire time for questions and answers, but if not, I had my own review questions from some other of the sections that were there. Friday's going to be the test. Okay. So, all right. Anybody else with something, please? Otherwise, we're done. All right, that's it for today, folks. So any other questions you might have, bring it up tomorrow, and then Friday's a test. All right, have a good day, everybody. See you next time. Thank you. Bye.